Let's revisit the tree problem. I changed the numbers a little bit. Let's say you measured a tree and it was 20 inches tall. 1 month later, it was 27 inches. Find the equation of the tree growth and graph it. Assume the tree grows consistently. In other words, the growth is consistent from this month to next month. We've done this several times, so you should be pro at this by now. Let's find the rate. It grew from 20 inches to 27 inches. So it grew 7 inches for how long? 1 month. So 7 inches per month. Let's make the XY table. X variable in this case represents month. X variable represents what's in the denominator of the rate, which is month. Y is what's in the numerator, which is height in this case. It is important to figure out which variable represents what. Month 0 is when you measure the tree for the first time. How tall was it? It was 20 inches. 1 month later, it was 27 inches. So it grew 7 inches. 2 months later, 27 plus 7, it'll be 34 inches. 3 months later, it'll be 41 inches. Now let's graph this. One, 2, 3, 4, 5, 6 months. So for the x-axis, it is number of months. For the y-axis, let's set this as 10, 20, 30, and 40. 10, 20, 30, and 40. It'll be height. For the month 0, it is 20 inches. So here is 0. And where is 20 inches? Right here. For the month 1, it is 27 inches. Here is 20, 25. So a bit higher than 25. For the month 2, it is 34 inches. Here is 35, so a bit less than 35. For the month 3, it'll be 41 inches. Let's put it on the right mark. So for 3, it is 41. It's a bit higher than 40. And draw a line. And here is the graph. Let's figure out the equation. The rate is 7 inches per month. So the equation is y equals 7x. But for the month 0, it is 20 inches. If you just plug 0 for x, then y is going to be 0. So we add 20. Then when x is 0, 0 times 7 is 0, and 0 plus 20 is 20. For the month 1, 1 times 7 is 7, plus 20 is 27, and so forth. This is a very typical form of linear equation. This is called y-intercept form because it is very easy to find the y-intercept. The term without x or y variable is the y-intercept. Y-intercept means the graph meets or it crosses the y-axis. So graph is here, it meets the y-axis right here at 0, 20. So that is the y-intercept. At y-intercept, what happened to the x value? X value is 0. It seems pretty intuitive right now, but many students get confused because there are more terms to remember later. And the coefficient of the x term. Coefficient means the number part of a variable. So the coefficient of the x term is called slope. The slope tells you how steep the graph is. If the number is bigger, the graph is going to be steeper. If the number is smaller, then graph will be closer to flat. And depending on the slope, it can go the other way like that. We'll talk more about slope later. Now let's set some boundaries of this graph. X is greater or equal to 0, and y is greater or equal to 20. There is an old temperature chamber. The temperature is set to rise 4 degrees each year. It is 10 degrees this year. Find the equation of the temperature change and graph it. Set this year as year 0 and assume the chamber has always been on. Let's find the rate first. The rate is, it is set to rise 4 degrees each year, so 4 degrees per year. And let's draw a XY table. X is year and Y is the temperature. The year 0 is 10 degrees. So this year is 10 degrees. How about next year? Next year will be year 1. And it'll rise 4 degrees more. So it is 14 degrees. Year 2 will be another 4 degrees higher. So it'll be 18 degrees. And so forth. The equation is y is equal to, the rate is 4 degrees per year, so it is 4x. When x is 0, the temperature is 10 degrees. So when x is 0, it is 10 degrees. So add 10. Let's think about what happened in the past years. If this year is the year 0, what year is the last year? It'll be year -1. And how about the previous year? 2 years ago will be -2. 3 years ago will be -3. And -4 will be 4 years ago. What are the temperatures in these years? -1 times 4 is -4, plus 10 is 6. -2 times 4 is -8, plus 10 is 2. -3 times 4 is -12, plus 10 is -2 degrees. -4 times 4 is -16, plus 10 is -6 degrees. And let's graph these. year 1, 2, 3, 4, 5, 5, 6. And the temperature will be 5, 10, 15, 20, and 25. Year 0 is 10 degrees, so where's 0? 0 is right here. It is 10 degrees. Year 1 is 14. Year 2 is 18. And where will be these negative years? It'll be the other side of the y-axis. So negative 1, negative 2, negative 3, and negative 4, and so forth. Also for the y-axis, it'll continue on down here, negative 5 degrees, negative 10 degrees, negative 15, and so forth. Negative 1 and 6 will be negative 1 and 6, negative 2 and 2, negative 2 and 2, negative 3 and negative 2 will be negative 3 and negative 2 should be somewhere down here, so it's right on that number. Negative 4 and negative 6 is negative 4 and negative 6 is over here. Draw a line like this, and the graph will continue this way as year increases. With the same settings as the previous problem up here, the temperature of another chamber is set to decrease 4 degrees each year. Find the equation and graph it. Let's find the rate first. Is the rate 4 degrees per year? 4 degrees per year means as year increases, the temperature also increases. But it is set to decrease 4 degrees each year, so it is negative 4 degrees per year. Let's make a short XY table. X is still the year, and Y is the temperature. Year 0 is still 10 degrees. How about year 1? Year 1, 4 degrees less than the year 0, so it'll be 6 degrees. How about year 2? Another 4 degrees less, it'll be 2 degrees. And the equation is going to be y equals, the rate is negative 4 degrees per year, so it is negative 4x. And when x is 0, y is still 10, so we add 10. And let's find a couple of negative years. Year negative 1 will be negative 1 times negative 4 is positive 4, plus 10 is 14 degrees. And year negative 2 is negative 2 times negative 4 is positive 8, plus 10 is 18. Let's graph this on the same plane. 0 and 10, 0 and 10, the same point. 1, 6, 1 and 6. 2 and 2, 2 and 2. Negative 1 and 14, negative 1 and 14. Negative 2 and 18. 18 here. And we'll draw a line. So this is graph for y equals 4x plus 10. And this is y equals negative 4x plus 10. I want you to remember, if x values increase as y values also increase, then the graph will go this way. Also, the slope is positive. If x values increase as y values decrease, the graph will go this way and the slope will be negative. And here is a set of vocabulary I want you to know. First, y-intercept. If I say, where is the y-intercept? Then you should be able to locate it on the graph, which is right here, or in the equation, right here, or here. If we call the point where the graph crosses the y-axis y-intercept, what do you think we call the point where the graph crosses the x-axis, which is right here or here? We call it x-intercept. Also, x-intercept. So remember x-intercept and y-intercept. We'll talk a lot more about these later. Also, the slope, whether it is positive or negative. One more term called quadrant. This two-dimensional plane is divided into 4 sections called quadrants. Here's the first quadrant, second quadrant, third, and the fourth quadrant. If I say there is a point here, and which quadrant is this in? Then you should be able to say it's in the fourth quadrant. Or if I say which quadrant is the point -3, -5 in, then you should say it's in the third quadrant because the point -3, -5 is right here. Try to remember all these terms before you move on to the next lesson. There are 300 yards of paper on a roll, and a cutting machine cuts the paper 20 yards each minute. Find the equation of how much of the paper is left on the roll related to minutes and graph it. Keep in mind, it is not about how much the machine cuts. It is how much of the paper is left on the roll. Number 2, what are the slope and the y-intercept? I will set 2 minutes and begin.